Resume. Okay, so what's up, Internet? Okay, today we're going to talk about absolute value. Absolute value, as you can see, I've got written here, is always always a positive number. Okay, let's the accoutrements out of the way. Absolute value is the distance from zero on the number line, and distance is always positive, right? Even if you're going backwards, you're still increasing. Doing here. And the way we show absolute value is two vertical lines. Let's say the absolute value of 5 is, now remember, the absolute value is always positive. So really what this is saying is how far from 0 is 5 on the number line? 5, right? And the absolute value of -5 is also 5. Always positive. So if we have the absolute value of A is 3, how much could A be? How much could A equal? Plus or minus 3, because the absolute value of 3 is 3, and the absolute value of -3 is 3. Now, what if we said the absolute value of X is -12? What would this be? Undefined. Or the null set, because absolute value is always positive. Now, if we have this, if we have 2x minus 4, the absolute value of 2x minus 4 equals 6. The helicopter taken, National Night Out. The helicopter taken off from, I live right next to a park. Okay, so we have 2x minus 4 is 6. I'm sorry, the absolute value of 2x minus 4 is 6. So we have two possibilities here. We have 2x minus 4 is 6. Now see, now we took it out of the absolute value sign. Or actually, and 2x minus 4 equals -6. Now it can equal negative because it's out of the absolute value sign. Now we solve this very simple algebra problems. 2x equals 10 divided by 2, x is 5. And add 4 to each side. 2x equals -2. Divide by 2, x is -1. So if you plug these back into here, if we put 5 in here, 2 times 5 is 10, 10 minus 4 is 6, and the absolute value of 6 is 6. Now if we put -1 in here, 2 times -1 is -2, -2 minus 4 is -6, and the absolute value of -6 is 6. So we are correct. Let's drink. Okay, these are real simple. Any questions on this? Everybody okay with this?
Yeah.
Oh, that's good. Mm-hmm. Now we do the same thing for inequalities. Mr. Jimenez, did you see this? Absolute value, that's what these little lines here mean. Absolute value is always positive because absolute value is how far is it from 0 on the number line. So the absolute value of -10 is this distance here. And how far is this? 10. Always positive. Now, for inequalities, we have this. If the absolute value of x is less than 5, we have two possibilities here. X can be less than 5, or x can be greater than, opposite sign, -5. And then how would we? 1, 2, 3, 4, 5. 1, 2, 3, 4. -5. X is greater than -5. And x is less than 5. So it's these numbers in here. Right. Okay, so the way we do this is we take x out of the absolute value sign, keep the sign the same, keep the number the same. Or we have x can be, it's actually and. X can be greater than the opposite sign and the negative number. Okay. What could be more fun? Okay. So if we have the absolute value of 2x plus 1 is greater than 5. This is the original problem. Therefore, we have, this is our original problem. So we have 2x plus 1 is greater than 5. Or we have 2x plus 1 is less than -5. Now we solve the equations, subtract 1 from each side. 2x is greater than 4, so x is greater than 2, right? Divide by 2. X is greater than 2. Same thing here. Subtract 2. Subtract 1 from each side. 2x is less than -6. Divide by 2. X is less than -3. Now, what you have to do here is check for what they call extraneous solutions. Extraneous solutions means solutions that are not valid, that are no good. So what we have to do is 1, 2, 3, 4, 5. 1, 2, 3, 4. -5. So x is going to be greater than 2 and less than, so we're talking about all those numbers, and x is less than -3. 1, 2, 3. Less than is that way. So let's take a number that's in this set of numbers here, 5. We plug 5 back into the original equation, or inequality. 10 plus 1 is 11. The absolute value of 11, is that greater than 5? Yes. So these numbers over here are good. Now what about -5? 2 times -5, -10 plus 1 is -9. Is that right? Is -9? Is that right? -10 plus 1 is -9. So we plug it back in here. Here is -9 less than -3? Yes. So what would this be? Negative infinity to, where are we? -3 or to positive infinity. Those are the interval notations. So everything there is true. Okay, let's see. Let's do this one. 2x plus 1. Absolute value less than 7. Okay, so if we have this, then we have 2x plus 1 is less than 7, and 2x plus 1 is greater than, the numbers flip here, -7. So we subtract 1 from each side. 2x is less than 6. Divided by 2. X is less than 3. Same thing here. Subtract 1 from each side. 2x is greater than -8. Divided by 2. X is going to be greater than -4. Okay? The number line, 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. So x is less than 3. Less than 3 is here. And x is greater than -4. -4 is here. So it's only these numbers in here. Now let's take 5, for instance. Now 5 is not in our area of answers. Put it back in the original equation. 2 times 5 is 10 plus 1 is 11. Is 11 less than 7? No. So we know that this area here is not in our answers. And we can do the same thing with the -5. 2 times -5, -10 plus 1 is, come on, stupid thing. -10. Was it -9? Now, the absolute value of -9 is 9. Is 9 less than 7?
Professor, excuse
Yes.
me, where did the -5 come from?
What?
Where does the -5 come from? Or it's just like a number we take from the outside of the...
Yes, exactly right. Thank you.
Oh, okay.
Yeah, thank you for asking. I'm just taking any number. That's,
Oh, okay, okay. Sorry, I wasn't getting that.
yeah, thank you for asking. I just took 5 because it's outside of our these are the answers that are true.
Right.
Okay, and we could take any one of these numbers and plug it in there, and they will work. Now, what we're looking for here are extraneous solutions. You're not going to see this word a lot, but you are going to see them probably more in your college class than here. Extraneous, Traneous. Extraneous means they're no good. They do not solve the equation. Okay, yeah, thank you for asking.
Thank you.
No, thank you. Now drink. Oh, that's good. Mm-hmm. 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 Okay. Mm-hmm. Now, polynomials and rational inequalities. What fresh hell is this? Good Lord. Who comes up with all this? Polynomials. Poly just means many. Nomials just means numbers, many numbers. And rational, R-A-T-I-O-N, rational inequalities. Okay, so what if we have this? Now we're finished with absolute value for now. Okay. X squared minus x minus 12 is less than 0. Now, we want the factors of, now if the linear term is negative and the constant is negative, we're going to get x plus something and x minus something. Because remember, the last thing we do in distributive property is the constants. A positive times a negative is a negative. Now, what are the factors of 12 of negative 12 that add together to give us -1, 4, and 3? Everybody okay with how we did this? Less than 0. Okay. So we have x plus 3 is less than 0, or x minus 4 is less than 0. Take each one of these terms and do this. So here we subtract 3 from each side. So x is less than -3. This one we add. Boy, my handwriting's getting worse and worse. 4 to each side. So x is less than 4. So we have this or this. Now, what is the interval notation going to look like? What's on the low side? What's the least this number can be? -3. And on the high side, 4. Both of these are in parentheses because it does not include the number 3. Now, to check, x is less than -3. 1, 2, 3, 4, 5. 1, 2, 3, 4. -5. So it's going to be between -3, which is here. Oops, wrong way. Less than -3, which is that way, I'm sorry. Or less than -3, and x is less than +4. Okay? So let's take a number. So to check, let's take 0. Plug 0 in for x. 0 minus s. So is -12 less than 0? Yes. So this area is good. Now let's take -5. Plug it into here. -5 squared minus -5 minus 12. Is that less than 0? -5 squared is 25. Minus a -5 is a +5. Minus 12. So this is 30. Minus 12 is 18. Is 18 less than 0? No. Everybody see that? No. This is not in our area. Now let's take +5. And we get plug 5 in. We're going to take this number right here, which is outside of our area. So we get 5 squared minus 5 minus 12. Is that right? Is it less than 0? 25 minus 5 and minus 12 is minus 17. Is that less than 0? 25 minus 17 is, was it 8? 8 is not less than 0. So this is not in our area out here. So it's only these numbers in here. Only those. So let's check a number in between here. In between, what is that? -3 and 4. Well, let's take 0. 0 is an easy one. Or did we already do that? 0 minus 0. So we're left with -12. Is -12 less than 0? Yes. Oh, we already did that somewhere. Okay, so that one is. So it's only these numbers right in here. Okay. You have to check. And let's do another one of these. X squared plus 3x minus 28 less than 0. So we want the factors of -28 that combine together to give us 3. -28, let's see, 2 times -14, no, 3, 4, 4 times -7, is that right? There it is there, huh? Yep. So this is going to be x plus 7. Oh, stupid boy. X plus 7 and x minus 4 less than 0. Less than 0. Let me rewrite this. So we have x plus 7 is less than 0 and x minus 4 less than 0. Okay, so we subtract 7 from each side, so x is less than -7. And here we're going to add 4, and x is less than 4. Okay, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4. -5, 6, 7. Okay, here's one of our answers. -7. The other one is 4. So let's take numbers that are in between. Let's take 0 because it's easy. Plug 0 in here. 0 plus 0 minus 28. So is -28 less than 0? Yes. So this area in here, well, let's take -5 just to make sure. Or no, let's take a positive number. Let's take 3. 3 squared. We're going to plug it into this. 3 squared plus 3 times 3 minus 28. Is that less than 0? So we have 9 plus 9 minus 28. Is that less than 0? 9 plus 9 is 18. So negative. Come on, stupid. -10. Come on, stupid, think. 99 is 18. 18 minus 28 is a negative 10. Is negative 10 less than 0? Yes. So we know that we highly suspect that this area right in here is yes. Now let's take a number that's outside. Oops. Let's take positive 5. Okay, so we have 5 squared plus 3 times 5 minus 28. Is that less than 0? 5 squared is 25 plus 15 minus 28. Is that less than 0? 25 and 15 is 40 minus 28. Is it less than 0? 40 minus 28 is 12, a positive 12, and that's not less than 0. So we know that this is not in our area, and neither is that one. So what is our interval notation? What's on the low side? What's the least this number can be? Remember, it's going to mimic the graph. What's on the low side? Negative 7. What's on the high side? What's the most it can be? 4. And again, parenthesis because it does not include. Remember, less than, greater than, we use parenthesis. Less than, equal to, greater than or equal to, we use brackets. And remember, you solve inequalities just like equations with one exception. If you multiply or divide by a negative number, the sign flips. Look at that misery. Y'all proud of yourselves? You should be. Good Lord, look at that. Okay. Okay. Do one more and then we'll go. I know y'all work and I know this is a real pain to get here. Let's drink. Oh, that's good. X squared minus 4x minus 5 greater than 0. Now, again, for the linear term to be negative and the constant to be negative, it's going to be x plus something and x minus something. So what are the factors of negative 5? Negative 5 is a prime number, so it's going to be, and this one's going to be negative, so the larger number will be negative here, 5 and 1. Is that right? Okay, so we break each one of these, set each one of these not equal to, but greater than 0. So we have x plus 1 greater than 0, or x minus 5 greater than 0. Oh, excuse me. Subtract 1 from each side. X becomes greater than negative 1. And this one, we're going to add 5 to each side. X is greater than positive 5. So now we have this. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. Now x is greater than negative 1. Okay. Greater than negative 1. That's that way. or x is greater than 5. So let's see what happens here. Let's take negative 5. Negative 5 squared minus 4 times negative 5 minus 5. Is it greater than 0? 25 plus 20, right? Negative 4 times negative 5 is a positive 20 minus 5. So 45 minus 5, is it greater than 0? So 40 is greater than 0. So we know that this
Professor,
area here.
could you move the paper upwards a little
Oh,
bit?
I'm sorry.
Thank you.
Sorry, I'll do better.
It's all right.
No, I'm not going to do any better. So we know that this area here is good. Now, if we put 5 in here, don't take a number that's on the line. Let's take 10 because it'll be an easier number to deal with. So we have 10 squared minus 4 times 10 minus 5. Is that greater than 0? This is 100 minus 40 minus 5. So this is 55. Is 55 greater than 0? Yes. So this area here is also good. Now let's take a number that's not in our area. This should be an extraneous solution. Let's take 0 because it's easy. Oh, we have 0 squared minus 4 times 0 minus 5. Is that greater than 0? 0, 0 is negative 5. Okay, everybody see all this is 0? Is negative 5 greater than 0? No. So this is not in our area. So what is our interval notation going to look like? Remember, it's going to mimic our graph here. We're going to get negative infinity up to, now I've already forgotten what this is. Was it negative 1? And the union of means it's all of these numbers, not the intersection of, the union of. And what's on the high side is 5 and up to infinity. Okay, you really have to check all 3 areas to make sure that they're going to be correct or that they will work and they're not extraneous solutions. Okay. Okay. Okay, adding and subtracting radical expressions. That sounds like fun, huh? Why don't we save that for next time? You want to? Anybody want to do them now?
No, we can take them.
Let me just show you what we're talking about here. A radical, what is a radical? Square root of, please think, 5 plus the square root of 5. And we're adding here, not multiplying. So this is 2 times the square root of 5. What we're doing is we're adding the coefficients here. So if we had 3 times the square root of 7 plus 5 times the square root of 7, remember we have to have the same index. The index is this number right in here, which is a 2. If we don't write it, it's assumed to be a 2. And we have to have the same radicand. The radicands have to be the same. If they are, then you add the coefficients. So this is 8 times the square root of 7. We'll do more of this next time. Just to give you a kind of a heads up of what we're doing. Okay? Any questions? That misery with the absolute value and all that, not one of those super duper whiz bang important things, but you will see it occasionally. And that's about it. Y'all take care. No questions?
No.
No,
Okay.
Professor. Thank you for everything.
Thank you. Y'all take care.
You do.
You
Bye.
too.
See you
Have a good
Thursday.
one.
Bye-bye.
Bye.
Mr. Jimenez, you okay? Mr. Jimenez? Can you hear me?